Hi guys, let's today do the Leetcode 1047, which has been classified as easy, though it didn't really sound to be easy when you start doing it, when I started doing it. So basically I would say it seems easy, but let's just see if it is really easy. And what we're gonna do is let's read the problem description first. Given a string S of lowercase letters, a duplicate removal consists of choosing two adjacent and equal letters and removing them. We repeatedly make duplicate removals on S until we no longer can. Return the final string after all such duplicate removals have been made. It is guaranteed the answer is unique. Alright, so let's see the examples. The input is A, B, B, A, C, A, and the output is C, A, and let's see why. Because as we pass through this string, B and B are removed, so it becomes A, C, A, and then A and A is also removed, A, so you're left with C, A. So that's the idea. And he talks about other things here. Result of this move is that the string is ACA, and of which only A is possible, so the final string is CA, and that's exactly what we just went through. So and then we have these conditions that the length of the string is never going to be more than 20,000, and only English lowercase letters are allowed. So how are we going to give it a shot? One thing is, let's do this in C, because C string handling is kind of not as robust and as user friendly as Python's. So in C, we get to learn some pointers, we get to learn really about how the things are put in memory and stack and heap and things like that. So let's do this in C. And anytime we have strings, I always have to have indices to walk through them. So I'm guessing we would need at least a two indices, but maybe we might need more. So let's just start with two indices. We need a variable for the len, and so len is going to be nothing but strlen as the length of the string. So now let us see. So we have to do this in place. So we are not going to allocate any new memory. So how do we do that in place? One thing is that, as you know, let's write it here. Strings in C are null terminated. And what does that mean? That means that if you had a string like ABC in memory, this would be the letter A followed by the letter B and then followed by the letter C and then followed by this letter that is not explicitly visible, but basically you have a null character. That is how in C the strings are stored in memory. So that is a good thing to keep in mind. I'm not going to delete this, you can for reference. So now if that is the case, what we can do is our null termination actually can become the condition of the termination of the loop. So then if si not equal to, while si not equal to the, and now you may ask me that why am I using this, like why am I using condition of null termination rather than maybe I could have used si while I less than len and things like that. And the reason why I did this is, instead of saying something like I less than len and those kind of things, is because I'm assuming or I'm guessing that the length of the string would change course of the algorithm, because you would be, as you, for example, if we had things duplicate here, or even in this case, for example, we start with the length of the string 1 2 3 4 5 6. Indexing is done from 0, so 0 to 5. And when you remove this, and suppose you decide that I need to put this ACA, move back, so the length of the string actually becomes 4, right? But when the length of the string becomes 4, because you put null termination after that, that is why we should, I think it's a better. So, and then imagine we are still walking in the beginning. So if you had a len as the condition, that doesn't look very interesting. I would rather use the null termination, because we will be null terminating the new string as we go. So so that is that, and now let us see what we can do. So if si not equal to si, or if si equal to si plus 1, we have a duplicate, right? So if si equal to si plus 1, we have a duplicate. And take this case here, the I will be 0 in the beginning, but then that time everything is fine, 0 and 1, when these are 0 and 1. But when it is 1 and 2, you see they're the same. So then we need to move all the letters that are after these two duplicates. We need to kind of move to the left to basically get rid of these duplicates. And how do we do that? So let's have another index. We don't want to mess with I. Let I go its own way. Let's say j equal to I. And we say while, or we can say, okay, and what is k here? We need another index now, because j is where you would be writing into that index, and k is writing from. So what should be the writing from index in this case? K has to be definitely j plus 2, I'm guessing, because if you're starting with the characters at the position j, and we know that j and j plus 1 are the copy of each other, and we want to get rid of them, then we start moving the shifting characters to the left, starting from j plus 2. So having done that, what are our options here? Our options are that we are now what we can do is we can use a for loop, and the for loop initial condition, I would say, is nothing, because we already initialized these things here. But then the terminating condition of the for loop is going to be while k less than len. And it's very important to get that right, because if k is the index that is moving to the right, you don't want k to be more than len. I mean, it has to be up to len, but the len itself, I think we will have to modify. It's not constant. It's not something that is just set on line 5. So, and then j plus plus and k plus plus. What do? We just copy sj equal to sk, and after this loop is done, all we need to do is we need to make sure that k is now k we can leave as it is, but we know that all the current value of j is where the string pretty much terminates. So we say sj equal to, we have to null terminate the string, we have to bring the null termination. So that is that, and then the len is also reduced to j. And what we do is we use a variable here, which is kind of a boolean, but in C, anything that is not 0 is true, and anything that is 0 is false. So let's just use that property. We say int dup found, or I would say shifting done, or whatever the heck you want to call it. Just call it dup found. So we say dup found equal to 1, and there actually we should have initialized that to equal to 0. So we start the while, the first statement in the while, saying there is a variable duplicate found. We set it to false, 0 or false. Then we go through this check. If we go inside that check, then do found is set to 1. Now why the do found is set to 1? Because that is the case, and we will use that inside that if statement to do some manipulations. And what manipulations do we need to do? Now you see, if I was at this point pointing at 1, then what happens once we shift the characters left I plus so now it may be possible that if you continue to point at the character that was where it was pointing when we did the all this moving around and removing these duplicate characters, that we might miss the case that now we have two adjacent duplicate characters. So it makes sense if we really want to remove all the adjacent duplicate is to actually reduce the value of I, decrement the value of I, so that maybe when after shifting these characters are actually duplicates of each other. And how do we do that? We say if do found, if do found, then we would like to manipulate I. And how do we do that? That then if I is greater than 0, then I minus minus. This is the very important condition here. If do found, and else we just say that I plus plus. You see why we are doing this, because, and why this condition I greater than 0, because you do not want to make if I is 0, imagine you have a string where everything is a duplicate of each other, like A, B, 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 and I is 0, and we never actually are able to move forward because you have so many duplicates. We keep moving, shifting to the left. And if I is 0 and we have this I minus minus, I will become negative value, which is not very good for us. So we do have to have this check that if I is greater than 0, decrement, but otherwise just leave it as it is. So in this case, I would have been, after the first time going through this if, I would have been 1. But then if do found, yes, now we kind of consider the character to the left of that, and because I is greater than 1, we can reduce it, go back to the I equal to 0. But if we were here at AA, we don't want I to now become negative because there is a do found. So I is decremented in the case of do found, subject to the condition that I is greater than 0. It is left as it is if it is 0 already. Alright, so that is that. Now let's try to give it a shot. Now it's saying that we have to return the string, so let's make sure we do that as well. So return as, and I'm guessing this should take care of it. This is all we need. So do a run code. We have a problem, and the problem is that K was undeclared. This is C language. This is not a modern fancy languages which let you do whatever the heck you want to do. So here I is a K. Let's see now. We still have a problem. And runtime error. What is that? address sanitizer. We had a segmentation fault at unknown address. PC this signal is caused by aborting. Okay, so what happened here? Let's see. So IJK JI, as long as everything is being initialized, we should be in okay. So okay, so we you see the problem. These are the kind of problems which are interesting to fix in C language, because in C language, now let me ask you what would happen if I don't initialize I here. Because I is on the stack, it's a local variable in remove duplicates, and it's on a stack, and the values at a stack are basically pretty much garbage. And we come here with that garbage value and we try to dereference s, and we get a sec fault, so we have to initialize I think that probably makes sense to everybody. All right, we have our happy moments. So as we can see that it has been accepted. So now let's try the submit and see if that has more test cases. So if they all pass, and there we go. So it passed all the test cases. It's looking good. We can do some runtime analysis while we have time, and I see that what would be the runtime complexity of this problem, or the time complexity as they say. You can see that we are passing the string once while in this while loop, and so it seems to me on, but somebody might come and say here, well, you're also kind of all this shifting, and in the worst case you may have to shift all these characters n number of times. I'm guessing that, because imagine I give you a string like A, all A's, like 10 A's, which is even. Now you start shifting, you take the first two, they're already duplicate of each other. Now you shift all these from 2, j equal to 2 all the way to the 10. All these have to be shifted. Then we do the shift again. So the best case of course is on, because when no duplicates are found, we just walk through the string once and we're done. So that's on. But the worst case I would say is still on square. I mean, unless I'm missing something. What do you guys think? I would love to hear your comment. I it seems to have worked, but it's probably not the most optimal or most optimized algorithm for this problem. If you have something better, I would love to hear from you guys. If you can write in comments, and I would really appreciate. Feel free to subscribe to the channel if that is what is your inclination. But otherwise, I would see you guys in the next video. Hopefully we'll continue to do these interesting problems. They're always better than using your time in less productive ways. So I will see you guys in the next video. Until then, bye bye.